Welcome everyone. I haven't seen you in a couple of months now, so it's good to be back. Thanks to Chuck and Gordon in particular for standing in at the last minute. I had a work crisis and I had to bail out at the last minute. So doing that to Gordon, asking him to stand in the chair with very little preparation was a pretty big deal in my mind for him to do that. So thanks, Gordon. I know you're here. Appreciate that. Let's begin. Actually, before we get started, it's been a great week for outreach. Holy smokes, it's been busy. Wednesday, Pierre Martens and Shane Finnigan had at the Cecil Morrison Park. They had the fireworks display that they put on every. They've been doing it for how many years, Shane? 8 years now?
At least 8, yeah.
8 years. Fantastic show. Although it was cloudy and we didn't get to see the conjunction, I'm hoping somebody here somewhere traveled somewhere to go see the conjunction. Because I was hoping there'd be more photos and more images. And then, of course, yesterday, and John Thompson, you were there as well at the event at Cecil Morrison. Great fireworks, as I said, but no observing. And then yesterday, we had the annual Cube Gallery event, and that was a really special event. We had a couple of scopes that were set up, and some people that came by and enjoyed some really lovely views of Saturn, Crescent Venus, and Jupiter, of course. And there was a really blockbuster iridium flare that I was telling people about it. And you always I measured everything to make sure that we were in the right location, knew exactly where to look. You never know if it's just going to be a dud. All right, but this one turned out to be really special, and it was met with a lot of oohs and ahs, so we received the desired effect, that's for sure. Okay, with that, let's get started. I'm going to turn this thing off. So next slide, please. Okay, agenda is like typical. Standing in for David is Gary. Gary, you experienced in doing the sky this month? So I know you are, Gary. Following that, we have Al Scott is going to give a 10-minute astronomy news update. Shane Finnigan, this is a presentation I've been looking forward to for a while now, and I know a number of you have because I've seen emails popping up on the various astronomy lists. People are asking about where do you go to observe in the Ottawa and surrounding area. So Shane has done a terrific study, and he's researched and shared his findings here, which I intend to, by the way, post on our website perhaps in time. We're going to have a break, and of course, at that time we'll have door prizes. We'll pick up at least the raffle tickets for the door prizes, which we'll have at the end of the meeting. After that, Richard Alexandrowich is going to be talking about life on red dwarf systems and what makes for the potential for life. We have members' observations, of course, and then a couple of announcements. So, all right, new members. So 29 new members this year. Philip, David, John, Sean, and Daphne. Are any of you here today? If you are, say yes. Okay, it's a July. So. Anyhow, welcome to you. It's always nice to have to new members, and I'd love to see you out at our star parties and other outreach events, and just to find out what interests you. Members in the news. Well, actually, this month there's really nothing. So, but I know of something, and I can't say because I'm bound to secrecy about something that I'd like to share, but we'll share it in the coming months. But there is something in the news that is worth sharing, and that is that the RASC bought Sky News, Sky News magazine, and that just hot off the press. So what I know about it is it was purchased as an investment, and I'm sure that there is some other reasons in terms of sort of further the spread of our message, into generating interest in astronomy, advancing interest in astronomy. We'll know more about this in the next couple of months, and particularly what it means for us, and where we're going with this, and I think probably a good question to ask is how it benefits some members, but somebody's bold, somebody's looking to the future. I wouldn't have expected something like this, but. I think the leadership we have right now in the national office They're different than previous leadership, that's for sure. And they're doing things differently. And I find that a bit refreshing, because I don't want to see the same leadership from like we've had for years, which is not a bad thing. It's just I think sometimes it's nice to have a bit of change and difference. Okay, with that, we begin with this guide this month. So thanks, Gary, for standing in for Dave.
Thank you, Mike, and good evening, everyone. So just filling in for Dave. Dave is doing a great job since I've decided to retire a couple of months ago. I've been doing it for a few years, but again, just like the RASC head office, new blood's always good. So can't get rid of me, but Dave is doing a great job. So welcome to Skies this month for July 2015, or the second half of the year. Next slide, please. Well, this month you'll see we have 2 full moons. One on the 1st was during Canada Day, and will be also on the 31st, a blue moon. Just simply the name given to the moon will not turn blue, but with the forest fires in Saskatoon, they might see blue moons, because forest fires and even ash from volcanoes tends to change the moon and the sun to a blue color. Next slide, please. Mercury is not visible, but when it does, we'll tell you. Stay tuned. It's just too close to the sun, so it cannot be seen. Next slide. Yeah, New Horizons, another few days from now, but 10, 11 days will move to close approach to Pluto, Mickey Mouse planet. No one wants to go there. But almost 10 years it took to get there. September of 2006 it launched from Earth. So it was a long trip for sure. So finally we get to see the last planet of the solar system. But Pluto has been demoted many, many years ago to a minor planet, because it really is actually smaller than the moon, so it didn't follow any other characteristics of the planets of our solar system. So still, it's great to see something close up like this. So we will wait for bated breath to see the images. Next slide. The the Delta Aquarid meteors, or the South Aquarids, will be visible at the end of the month on the 28th at 3 a.m. because the radiant, or the constellation, does rise late. It's only about 15 to 20 meters per hour, so it's not a colossal event, but still, it's really something to see, and you'll never know. You might see fireballs or something. Mother Nature has her way of shooting these little curveballs at us. So go out, it might be a storm, you never know, but really it's a no-name shower pretty well. Okay, next slide, please. Okay, in the sky, Venus. Who has not seen Venus this month? Raise your hand or shout it, I have not. Say it loud and proud. Yeah, Venus and Jupiter are really putting on a great show. In fact, now are pretty well horizontal to the horizon and will set the same time, i.e. spooky eyes. So you have about another 10 or 11 days, or maybe a little more, to photograph. And also on the 18th of July, the small crescent moon, only 9% lit crescent moon, will be just below Venus. So a great digital moment will be seen then. And Mars not visible, but again, we'll tell you when. Next slide, please. Jupiter, just mentioned, just doing a great job. Will be lost along with Venus in the solar glare pretty soon, but toward the end of the month, and then a few weeks later, be in the morning sky. So those waking up early will see both together again. And next slide. Saturn, of course, the ring wonder, the Lord of the Rings, easily seen all night long. It's in Scorpius. It's a yellowish star. Just look for Scorpio, which I do have a slide later that will show that if you've never seen Saturn. Who's never seen Saturn in a telescope? Say it loud and proud. Great. Okay. And Venus too. Those people, true, going back to Venus, those have not seen Venus in this phase setting, because Venus is now between Earth and the Sun. Beautiful crescent phases. You really have to look at Venus now, other than getting up early in the morning. Next slide. And Uranus and Neptune are out there, or at least they don't move too far. And next, I think that'll be it. The International Space Station, best seen on the second to last day of the month. It'll be 88 degrees overhead, pretty well right overhead. And here's a great slide to show. Of course, I do have a link on my website, wondersofastronomy.com. I do have a link for all sightings over Ottawa, which is automatically updated. So if you do want to see a chart like this, just click onto it and away you go. And next. And we'll let you read the cartoon. What time of night do you think this cartoon was meant to be at? Early morning? Very good, yes, because that is a waning crescent moon. It always gets me in cartoons, especially little kids' cartoons, they always show the waning moon. That's like at 3 o'clock in the morning. Kids shouldn't be up that early, or that late, that is. So I think that's it for this month, and Mr. Chisholm should be back next month to wow and dazzle you, and have a great month, folks. Take care.
Thank you, Gary. Great. Next up is Al Scott with his usual monthly segment on what's new in astronomy for the month. Thanks.
Thank you. All right, so this month, what's new? I thought I'd give you an update on the Rosetta mission. This is the European Space Agency's probe that's actually orbiting a comet at this very moment. And here we see a picture of the comet 67P Churyumov-Gerasimenko. And you can see it's becoming active as it's approaching the sun. There's dust coming off the comet now, vapor escaping, and the probe is taking images. It's backed off from the comet to about a 200-kilometer orbit to avoid some of the dust that's coming out. It was originally in closer, getting higher resolution shots when the comet wasn't quite so active. And one of the results that the scientific results that have come out of this mission is because of the high resolution imagery, they've located the source of the jets that are coming off of the comet. And the source of the jets are these sinkholes. And so they have a theory that as the comet heats up from the sun, there are various theories as to why this is happening, but what typically seems to be happening is that the crust is collapsing or being blown away, and the material along the edges of this pit, which has been protected by the crust, suddenly it gets exposed to the solar radiation, and all of the volatile ices sublimate and start entraining dust and shooting up as jets. So a very interesting discovery. And one other item that I'd like to talk about that has made this into news, this is an actual request, is to talk about a resurrection. The Philae lander has come back to life after being dead for over 6 months, and contacted the mothership, the Rosetta probe, which is kind of neat. Hidden by shadows, Philae shut down on the 15th of November 2014 after completing its main science operations, where its primary battery expired after 60 hours of operations on the surface. On the evening of the 13th of June, a weak but solid radio link between Rosetta and the lander was finally reestablished for 85 seconds. More than 300 packets or 663 kilobits of data, housekeeping telemetry, were received by the orbiter. We know from this brief snippet that all of the lander subsystems are working nominally with no apparent degradation over that period, which is amazing because it's been cold. A second smaller burst of lander data was received on Sunday, June 14th, for about just a few seconds, which have given Rosetta the current status of the lander. It's warmed up now, its internal temperature is warmed up to -5 degrees Celsius. And they know now that they believe that the lander landed in a ditch or a valley so that it couldn't get enough sunlight on its solar panels, and that's why its battery drained out earlier in the mission. It was supposed to have a limited lifetime anyways, but they had hoped it would operate for longer than just the main battery would allow. There is a secondary solar panel and a smaller battery that should be rechargeable, and that's what's allowing the lander to contact the main probe. And so the comet is now getting closer to the sun, so more sunlight is reaching the solar panels of this probe. And they find that when sunlight starts to fall on the panels, it generates about 13 watts, and by the end of the sunlight window, it gets up to 24 watts. And the lander needs 19 watts to activate its transmitter. So, and what it's happening is about a 2-hour window each day that it's getting sunlight. The comet has about a 12-hour rotation period, so 2 out of 12 hours, the lander is receiving power, and it ramps up to be able to turn on its radio transmitter, and it tries to contact the Rosetta probe. Scientific data are stored in 2 mass memories on the probe, on the Philae lander, and in order to download the data, a stable link duration of about 50 minutes is desired. It can take around 20 minutes for the data to be dumped from each one of the 2 mass memories to the orbiter, and additional time would be needed to upload more commands to the probe to do more studies. So after this contact back in mid-June, the Rosetta mission planners have been adjusting the Rosetta orbit to try to bring it more in line with where they think the antenna of the lander is pointed. Because the antenna is fixed and it has basically a cone that it illuminates with its antenna pattern, and it's kind of parallel to the surface of the comet right now. It's shooting out to one side, and the latitude that the Rosetta probe was orbiting wasn't intersecting that cone very well. So they've been adjusting the latitude of the orbit, and they're now trying to bring the orbiter down closer from 200 kilometers, and it should be down to around 160 kilometers this week. Confirmed contacts between Rosetta and Philae have been made on the 13th, 14th, 19th, 20th, 21st, 23rd, and 24th of June. But were intermittent during those contact periods. They haven't been able to establish a good, stable, repeatable orbit and contact. That's not surprising because the Rosetta orbiter has to be over top of the lander during that brief period where its energy, its power, is above 19 watts when it turns on its transmitter for that 1 or 2 hours of the day. So there has to be a certain sequence of things to happen. And the original antenna was designed to work out to about 150 kilometers, and because Rosetta had backed off to 200 kilometers, it's not a very stable link. And that's because of all the dust that's around the comet. The actual Rosetta probe uses star trackers to tell it which way to point. And it's looking at the stars with these cameras, and it tells it what its orientation is. And if the dust particles fly in front of those cameras and are illuminated by light, they look like stars, and they could confuse the probe and make it spin off. And in fact, when the probe went by in March for a close flyby of the comet, it went into a safe mode to protect it because it lost orientation control. And the mission controllers don't want that to happen because it could take them weeks to bring it back from safe mode to operational mode. So they're being very careful in how they try to bring this system back up into an operational state. And it's an interesting problem to get it to work at exactly the right time. This image shows a close-up of a crater on what they would call the north axis of the asteroid, where they believe the lander to be. You can see on the image an ellipse. They call it the concert ellipse. This is an uncertainty range of where the lander is expected to be based on radio signals received by the Rosetta probe. And there's a close-up which is zoomed in on the upper right here, which show before and after landing of a certain area very close to that ellipse, which seems to indicate a bright dot that could be the Philae lander at about the right size. So it's possible that you can see the post-landing photos are blurrier than the pre-landing because the probe has backed off from the comet, so it's further away, so it's got less resolution right now than it did earlier when it was closer in. So it looks like there's a possibility that the resurrected Philae may be able to download its data and continue some scientific investigations on an active comet. What they hope to do with this probe is it actually has a drill, and they hope to drill into the comet and measure the volatiles in situ in the comet. So keep your eyes open for this in coming weeks. We're hoping that they can reestablish a stable radio link and start to download the science data that's been sitting on this for over 6 months now. And that brings me to the end. Thank you.
Actually, Alec, just some quick questions. I got one too, but why don't you start? Somebody else has a question first.
As it gets closer to the sun, when will it become too hot? So what's the window of science before it's too late?
That's a good question. I don't really know whether there's a too hot point for this comet. I mean, it doesn't get that close to the sun. It's, I think it's within another 2 months it'll be at its closest point to the sun. So I'm not sure that's necessarily going to be a problem. It's mainly a question of whether they can they can pick it up before something goes wrong or a dust particle destroys it or it gets coated with gunk from the comet, perhaps.
Another question?
What size are those boulders we're seeing?
The Philae lander is on the order of a meter. So you can see, and that's about 2 or 3 pixels in the upper right zoom in. So those would probably be hundreds of meters. Yeah. Some of the larger ones would be hundreds of meters.
So Al, I got a question. Why wouldn't the Rosetta orbiter maintain synchronous orbit right above Philae? What would be the reason for not doing that?
The synchronous orbit altitude above Philae is very low. To actually get into a synchronous orbit, I think the orbit they're in right now is just not close to it. So I don't think that would, perhaps as a last-ditch effort, when they get close to the end of the mission, they're definitely going to plan to bring the Rosetta probe in very close until it either loses lock or crashes. So I think they would probably, bring it in closer as the mission progresses and as they're willing to take more risks once they've got over some of their other scientific goals.
Okay, and I take it, as you said earlier, they're steering, as the Rosetta revolves around the comet, it's steering clear of the dust tail?
Yeah. It's all a question of keeping it alive for its other ongoing science missions while taking a level of risk that they're comfortable with. So they're taking it somewhat slowly to establish the orbit. So right now they're adjusting the latitude of the orbit so that the orbit plane passes through the cone of the lander's antenna.
All right, folks. Any other questions?
I have a question. Does it have enough gravity for to be able to drill? Because the tanks didn't.
Yeah, that's a very good question, actually. The question was, does it have enough gravity to be able to drill without flying back off into space or spinning itself around and perhaps going into a new orientation? And I'm not sure anyone knows that. The lander was equipped with spikes on its landing gear that were supposed to smash into the ice and anchor it when it landed. And it also had a harpoon that it fired at 70 meters per. It was supposed to fire at 70 meters per second out of the underside of the probe. At the same time, fire a retro rocket on the back of it to dampen the momentum change due to firing the harpoon. Well, the harpoon didn't fire and the retro rocket didn't fire. The only thing that happened was it touched down and bounced and wobbled away and almost actually left permanently. It was a very high bounce. It was like a couple hours, I believe, before it came back down. So, yeah, it's not certain whether it will be able to penetrate with the drill. I think it's up in the air at this point.
Yeah. I think I heard that the Philae lander with the gravity now weighs about a gram. It would take much for it to bounce off.
Yeah, not a lot of force. Not a lot of force you can put on a drill if you only weigh a gram.
A lot of questions.
Considering all the problems they're having with their solar battery and knowing what kind of a rough terrain they landed in, why did they not consider, these scientists, using an atomic battery? Look at the Voyager craft, 35 years old, and the atomic battery is working beautifully way beyond Pluto. Why did they not use an atomic battery, and then we could get some useful information?
That is actually a good point. I think the scientists would have loved to use a nuclear generator on board this, similar to the ones that have worked for years on Voyager, but I think it's more political than scientific in the case of not using nuclear batteries.
Availability issue.
Is it?
Then you have new dimensions.
Oh, the comet. It's not very big. I believe it's a few kilometers. I don't have it at the top of my mind right now, but I think it's a few kilometers, 6 to 8 kilometers is I'm just recalling, though, from the last time I presented on this several months ago.
Maybe one more question. How much power is needed for that drill?
I don't have that data right at hand, but the Philae solar panel, we're supposed to provide it with a peak of 32 watts of power, and it's getting up to 24 right now during its brief daylight. So I think what they're hoping to do is to power one system at a time on the lander and operate, the drill and then the transmitter. But first they have to have a stable orbit where they can download the data, or else there's no point.
Okay, thank you, Al. A lot of questions. Great. Just want to put this back for a second. Isn't this a nice image? I mean, I was looking at Al as he was speaking, and what a terrific backdrop for Al. Okay, up next is Shane Finnigan, who's taken on talking about observing sites in the area.
Talking about something, anyways.
So, right?
I'll try to master it this time.
Later.
Yep. All right. So when I discovered I was going to be doing a talk on the best observing sites around Ottawa, I couldn't help but produce a page like this because it just seems so pretentious to actually think that I'm going to come up here and tell you what the best sites are. I'm sure all of you have gone out and observed. You have your favorite sites, and I realized that, this needs a bit of editing, so I did a few things. First of all, popular sites would be a better way of saying it, and sum up, because I know there's many more sites out there. I couldn't hope to cover them all. And then I wanted to cover a few other things too. But mostly, I kind of look at this as kind of like, what's the best telescope? That's a can of worms. You're never going to answer it correctly, and you should never even try. It ultimately comes down to whatever you use the most. And it's the same thing with the observing sites. As you probably know from previous presentation I did, my favorite observing site for solar is my backyard. It's safe. I can set my scope up and not worry about it when I leave it unattended. It's close, and I use it often. And if you use that as your criteria for observing sites, you can't go too wrong. So here's a picture of me out standing in my field. Actually, this is a picture of Nirvana last year. And I thought this was a good picture to, show one of the prime observing sites that people use, and also to try to explain how I got into being asked to do this presentation. How did I get volunteered to do this? I'm not quite sure, but I think it has something to do with this. A little too slow to run. Got blinded by the light. I may look svelte, but you know what? I got caught. And it's always a good day when you can use a word that has an S and a V following it. So, svelte. I like that word. It's a good word. Anyways, onward to something more constructive here. The nut of the idea was that there was no one good place to go to find out where some of the observing sites were, what the favorite sites were, and just some general information, like beyond opinion, saying, oh, this is the site to go to, this is my favorite, but, where do we go to observe? So what I did was I took a picture and I compiled the more popular locations, and I purposely put in gray some of the older sites that are no longer used, because these things change over time. Access to properties, different viewing conditions, and just plain old popularity changes where we observe. So, as an example, in the top left, that's the Bonnechere airfield. Well, that's no longer even accessible to us, and I know that some observers have been specifically told not to go there anymore. So, this was a good example of how the observing sites evolve, and they always will. So it's always a good idea, and that's why I want to talk about a little more than just the specific sites, because I thought, I could wrap this up in like 3 minutes and not necessarily tell anybody that's, if you've already observed, I haven't told you anything new or different, or maybe left you with a thought, and that was, why are the sites popular, and what makes for a good observing location. It may seem obvious at first, but if you think about it a little bit more, you go, oh, you know what, there's actually a little bit more to be said about it. And that's more specifically like the microenvironments and the darkness of your site. And then, of course, I'll cover the observing sites, and I have one ending thought to discuss. So first and foremost, I talked about it a little bit, and that was what makes a great observing site, and that's the ones that you're going to use. So if you find that it's safe and accessible, you're going to use it, but that's relative to the observer. And I mean, we're all each different. We each have our own preferences and what we consider safe levels, and some people might not be so comfortable in a place like Nirvana, which is a more remote location with no cellular coverage. So these are all things that you have to consider. But the next two sites, or ideas, are, or points I should say, is a clear view of the sky, obviously, and is the sky dark enough to do the type of observing that you want to do. More relative to the location, and that's what I'd like to talk about a little bit more. So did a bit of cross-referencing and researching, and in the book by Jean Texereau, How to Make a Telescope, he specifically states that obviously putting a telescope up in space around the moon to free yourself of the atmosphere is the best place. Great, but we don't quite have that budget, or most of us don't. So the next thing you have to consider is, okay, well, aside from being able to travel anywhere in the world whenever we choose, we're pretty much locked to a physical location of where we work and live. And that's what he talks about, the ideal observing site to your locale. And that was basically you're looking for a large open area, grassy area, but obviously if you're in the desert area, it wouldn't be grass, it'd be just the sand. But the point is that you want to get in an area that's large, flat, and doesn't have too many thermal masses in the area that can re-radiate heat at night and cause disturbances in the air. And then, of course, on hillsides, something to be considered is it can have the convection of air. So air, or the heat, will actually rise up a slope of a hill, and then you'll notice that your observing is not going to be as good as you had hoped. You figure you're going to get yourself up higher, but it doesn't necessarily help you. So here we are observing in our city, and of course we're battling light pollution, and as you can see, our object is hazy, and we're dealing with the heat radiating off of our driveways and houses and cars and everything like this, and our poor little observer is not having such a great go of it. So he decides to pack up, and actually, before we do that, we'll talk about darkness. Sorry. In the book Telescope Optics, there's a specific section in there, I believe it's chapter 18. They speak specifically about contrast, mostly about the telescope, but they do touch on the part about the other 10 miles of your optical system, and that's the atmosphere. And that is, obviously, you want to have as much contrast as possible, because it is the single most important, or they feel in this book anyways, it is the single most important aspect of observing. You have to have good contrast in order to be able to observe the details. And also, things that will affect that would be your stray light, so any light source that's nearby, and I believe I covered that. Yep. So what I decided to do was I created this to show you an effect of contrast. And what I've done is, on the left-hand column, it's various colors, and I tried to pick colors that were close to planetary colors or different objects that we might view. And all I've done is the exact same dots moved across the page, and all I did was change the background color. And what you'll notice is, like the top green, very bright, distinct. Obviously the edges are frayed, but you can see that. As you move across, you'll find that it actually bloats out. The color of green changes. And then if you move down into the different colors, it's very difficult to see the grays. And in the other green down here, it actually goes darker. So this was just a good example, or what I was trying to find was a short and sweet way of illustrating the effects of contrast. So what I've always said was, when people were talking about telescopes, I want to get a bigger telescope and what have you, I said, before you do that, drive another 20 minutes. And what I mean by that is, if you're going to go to the dark site, go to a darker site. Try to go to, one level darker, just to see. And what you might find is you actually rediscover your telescope and see things that otherwise you'd never be able to see. So it's worth a thought and worth consideration, because contrast is, if you think about it, the single most important thing. That's why we can't see the stuff most of the stuff anyways during the day. So we go to the dark site, and we have this glorious night where we can see everything nice and clear because we're in a nice open field, there's no heat being radiated, and it's just bliss. So then we have some forest fires in northern Ontario and in Alberta, and we have a volcano in South America, and so long as the wind cooperates, everything's just peachy. But if the wind turns around, all of a sudden, seeing goes bad. And he's back to his exasperation. And the truth is, last summer, a good portion of the summer, I found myself anyways, was you'd go out and the sky just didn't have the quality. Even though it should have had the quality, the clear sky clock said we should have the quality, there was the particulates in the air and it just muddied up the sky. And it wasn't until, I think it was late August or early September, we had a few heavy rains and it just seemed to wash that out of the sky, and all of a sudden the sky came back and we were getting some really good viewing. Now, some of you may have had different experience, but that was something that I could directly relate to say, these things definitely do matter. And even if they're miles and miles and miles away, they do affect the sky. One other thing that I find, okay, this is opinion, so I will give you warning, this is my opinion. Just through observing and traveling around, what I found was city centers. Actually, we all know that they have a heat island effect. And my feeling is that that heat and pollution island, if you are basically downwind of these large centers, there is an effect that I've noticed in observing where I try to avoid it now. I don't know if anybody else has experienced the same thing, but like I said, I personally try to avoid being downwind of a large city center for that reason. I do find it affects it. All right, so what I've done was I took the map that I had of the observing sites, and in my research I discovered that the light pollution map that some of you or all of you are probably aware of, there's actually two versions. The first version was actually created when there was snow on the ground, and it was later discovered that there was snow on the ground when that was created, so they created a second one taking into effect of the light pollution. And in doing that, we actually gained an entire light level. But what makes it useful is, what was pointed out to me earlier this afternoon was, this is actually great because we have two maps, one for our winter sky and one for our summer, or summer and spring and fall. So that would be for winter when there's snow cover, and in the summer, it gets much better. So same observing sites, and instead of being in orange and borderline yellow, you're definitely in yellow, and in the darker locations, an improvement again. So after this, I decided, okay, well that's great, but what's the commute time? And the only thing I could think of was, let's use the Dominion Observatory as a reference mark. If we were driving from that location, because we're all over the city, some of us outside of the city, so I figured I'm going to plant my flag there. It's the prime meridian for Canada. Makes sense to me. So what I did was I plotted out how long it takes to drive to each of the different locations, and within an hour, these are the locations. They all get you within roughly the same kind of sky quality, and that's Bootland Farm, Penny's Point, Carp, Heffalo, and Moose Creek. And then outside of that, we have the further destinations. You're definitely looking at a minimum 2-hour drive. Addington, Plevna, Nirvana, and La Vérendrye. La Vérendrye being the furthest, of course. And The only three that would get you into the truly dark gray skies on this map anyways would be Plevna, Nirvana, and La Vérendrye. And Plevna has an interesting history right now in the fact that it took so long for them to get it to fruition. And then the air ambulance decided to install lights at the airport, which immediately ruined the conditions there. So I understand that they cover the lights during observing times and then they uncover them. And there is a plan that is pretty much in motion now to have those lights changed to ones that are activated for when the helicopter is in the area. They'll click their microphone, the lights will come on. So that problem will be solved. So up next, what I decided was, or what I created was a map for each of the locations, and this is it. What I tried to do is keep it simple, keep it to one page. I learned long ago that your best way of communication is to try to keep it one page, and that way you'll hold people's attention and not drone on about stuff that's not important, so you skinny it down. So what I've done is a wide view map, and then a closer view map, and then of course a Google Earth type view. And what I provided for information was, if I had it, the street address or the latitude and longitude. And for like FLO, for example, it's approximately 50 minutes to Ottawa. You need a gate or escort to get access to it. Has some cellular coverage from what I understand. The amenities are 10 minutes away. It's accessible year-round, except after a major snowstorm, in which case you'll have to wait for it to be cleared. The observing area, that is important to a lot of people, obviously. It's about a 65-foot radius at the moment, and I understand that they're going to be topping some trees there to improve the horizon line. It's in a 4.5 on scale, or yellow, and the clear sky clock address is on the bottom there. When I did ask, basically all of the sites that we have for observing are either through the benevolence of people giving us access to their properties, or in this case, conservation area, or some other arrangements like that. So that gives you an idea too of the dynamics of these sites, because at any time we could lose access to a site just by, for example, let's use Nirvana as an example. If the ministry decides to return the land to the natives, there's a possibility that it would no longer be available to us to observe from. Just putting it out there to say, this is why we want to go out and continue to look for new sites as well. Because one, we could find better sites than what we already have, or additional sites. And there's always that possibility that there's the dynamic change of just reality. Next up is carp. Carp's about 30 minutes. I'm sure if you've done any of the public astronomy, you've been there, so you're aware of it. Again, all the same sort of information, what kind of amenities it has, what kind of observing area, the quality of the sky. And in the case of carp, this is only during RASC events that we have access to it. So that would be our public astronomy. Outside of that, technically it's not available. I'm sure you could try to observe from there, but if the police show up, they may ask you to leave. Bootland Farm. So Tom Bootland allows us access to this site, with the exception of during hunting season. That's listed down here as well, and then of course if the ground is too wet or covered in snow. It's about 15 minutes away from Arnfar, so good access to amenities. You've got cellular coverage there. About an hour away, and similar conditions to FLO. Slightly larger observing area at 230-foot radius. And again, clear sky clock down at the bottom. If you're unfamiliar with the clear sky clock, Attila Denko created this many years ago, and it's probably one of the single most used and useful tools out there to predict when a good night would be to go out there and observe. Moose Creek. Pretty much our only site to the east of Ottawa. And again, all of the information's there. This one's probably the most difficult to get to because there is no signposts or gates that are, or street addresses really. So what I did was I captured the street address prior to where we turn, and I provided the latitude and longitude at that intersection. So from there, you would drive up and you can see in the top right, we observe right at the very end of the road. Lennox Addington, it's a small pad created alongside the highway. It's about 100 feet off the road. And again, all the information's there. I don't need to keep saying the same thing. They do have their own website as well. If you, and I didn't include it there. I failed. Sorry about that, guys. If you do look it up on the web, you will find that they do have a website that briefly speaks of it, and most of the information's there, though, including the street address. North Frontenac, also known as Plevna. Again, very first piece of information there is their website, longitude and latitude, and yeah, very good observing site. It has power, it has bathrooms, it has a lot of things that a lot of sites don't have. So I know it's a popular site. Nirvana, that was the picture that you saw earlier with me. This one's a little difficult to get to, and it's definitely a little more wilderness setting. We've heard wolves, coyotes out there. If that makes you uncomfortable, then make sure you travel with a crowd, but I can assure you that if you do go, you will have a wonderful time. It's a very nice site. Last but not least, La Vérendrye, the furthest away. It's almost 3 hours. I provided as best the information as I could with respect to how to get there, and the Clear Sky Clock will also help you with that. But the information where I have, I believe it's, where is it here? Yes, on Highway 117. It's right after mile marker 322. If you follow those instructions, you can't go wrong. Last but not least, every decision we make has a consequence. Kind of profound statement, but something that's been coming up specifically with Plevna was first the helicopter lights, and now they want to build windmills. And apparently they want to build, I believe it's somewhere around 150 turbine windmills. This has been spreading across Ontario. My wife's from Southern Ontario, and I can assure you they are everywhere down there. And it's become the bane of people's existence to some degree. But it's an interesting debate. We give up coal so that we have this. But like I said, every decision has its consequence. So, did a bit of research. I discovered that in St. Isidore, to the east of Ottawa, they are actually building a 10,000 acre wind farm. To south of Ottawa, along the St. Lawrence, they already have windmills. They want to put more in, and there's a battle about that. And if you go to the Ontario Energy website and do a bit of research, you'll discover that our current number is about 1,850 in Ontario, and they want to double that in 10 years. So the problem's not going away. There's clearly a market for it. It's a political can of worms I don't want to discuss any more than the fact that I tried to think of something profound to say about this, and I kept coming back to the same image. And it might have something to do with the fact that where my computer monitor sits, the picture is directly above it in front of me, and that is this Carl Sagan and the pale blue dot. And the profoundest thing that he said was, it's the only home that we know, and we need to cherish and preserve it. And I think maybe that's what we should be thinking about when we make our decisions, regardless of what they are. Anyways, that's it.
Any questions for Shane? Anyone want to add anything?
A couple of years ago, RASC had some star parties out in Cumberland at the Government Heritage Museum. I don't know if that's anything that we're able to access. Oh, okay.
We had three security. We looked to have a art on the east side, and we had security. Sorry, again. Just one word on the windmills. I live in South Mountain on the 8th. Princeton is about 5 kilometers per hour. Yes, you have stroke during the day, but at night there are red lights that click on and off. So might not be that beneficial. And if you have any kind of tree coverage, just in my opinion.
Yep.
Because I was worried too about strobes at night, and I know there's no red lights, and anyway.
Yeah, it's an interesting position we're in because we have to make decisions, and like I said earlier, there's clearly a market for the electricity, like it or not. So we have to live with our consequences, and conservation is an option too. Just saying.
What aspect of wind farms is deleterious? Is it radiation, or are they illuminated, or?
There's a strobe light on the top of each tower to warn aircraft.
Actually, they're only about one every third tower.
Yeah, depending on the wind farm, yes.
The middle of the farm,
Yeah.
hardly affects it.
Yeah.
It works the rest of the day.
I know in Chatham they were having a lot of problems with the company, and there was a lot of battles going on. And it's growing pains to some degree, but they were building them so close to the local airport that the planes actually had to change how they were coming in to land. And it just got to the point where they actually had to take the tower down. It was just too dangerous. So the idea was to create a bit of a database so that we had a place to refer to if people were asking for observing sites. This is the seed, and I mean, by all means, if you have an observing site that you like or that you discover and you want to do the same, welcome to add to the list.
Do you know where the windmills are planted? Because that's an airport.
Well, that's why I mentioned about Chatham, because in Chatham, because it's very flat down in southern Ontario, that's why a lot of the wind farms are started down there. And now they're moving to areas where the wind isn't quite as good, but still within the marketable range. But around airfields, and specifically ones that are active and being used for air ambulance, I would think that there's definitely going to be some clearances, and they're going to have learned from their previous mistakes in southern Ontario and along Lake Huron. So let's hope. Anyone else? Yep. To go to Plevna? The way I understand it is, if you go to the website, they announce a lot of the, observing programs that they're doing down there. I don't know much about the covering of the lights, so I don't want to venture to say on that. But like I said, the ball is in motion to have that fixed shortly, and I would think that they would like to have it fixed for the summertime when the main observing is happening. But,
One more question?
yep.
Is it a farm, or is it a private residence?
Moose Creek is, it's actually a county road that accesses between the farm fields. So you're observing on the road, but it's a dead-end road. So it just goes in, and it's surrounded by farm fields. So it's actually quite good in that respect because it's open field and no heat radiation, right? Yeah.
So you wouldn't have any bodies?
Nope. Nope. In fact, there's a number of other sites that I didn't put on this list. Pitt Road, Soike Road are two that come to mind that they're basically dead-end roads that they're south of Cobden and closer to Pembroke. And both of those are also dead-end roads that people use. And even in the wintertime, because they keep those roads plowed, so you have some access.
All right, thanks very much. Thank you, Shane. Well done. Very well. As I mentioned earlier, we're going to. My plan is to post these Shane slides on our website, and we can add to it over time as well. Okay, we got some feedback here. A couple of things here. I wanted to say a few things about some of the door prizes. And Brian, do you mind coming up and talking about the two pictures you brought? Just saying something about them. But before we get to that, Brian McCullough, before we get to that, I wanted to say a couple things about membership benefits. So for those of you who might be coming here for the first time tonight, or maybe have been here a couple of times and are considering membership, let me just say a few things about what membership brings in the Ottawa Centre. We do have an observatory. I think we've talked a little bit about that, the Fred Lossing Observatory. We have a telescope loan library, an astronomy book library, which is actually right behind us. So if you wanted to check it out as a member or non-member, you can certainly check it out. Estelle is our librarian, and she can show it the books that are available for sign-up. With membership, you get the Sky News magazine, which comes 6 times a year, and the other publications, including the Observer's Handbook and our center's own astronauts and the RASC Journal. Membership an adult membership is $75, although there is a better membership if you're family. It's $70 for the first adult plus $11 after that. So 2 adults would be $81. Okay, so that's obviously quite a good deal. Brian, can you come say a few things about these wonderful prints that you brought? Oh, so we've got some exceptional door prizes. Chris, you want to get the lights?
Thanks, Mike. A number of years ago, an Ottawa Centre member, David Robinson, who was my mentor in astronomy and got me turned on to Ottawa Centre, gave me the couple of prints, gave them to my wife and me. One of the northern hemisphere, one of the southern hemisphere. So it's showing all the constellations as we like to see them in a different artistic way. And Bridget and I have enjoyed these at home for a number of years, and we cleaned up the dust from the top of it and everything like that. And we think they're still in good enough shape. Maybe that'd be nice in somebody else's home for a while. And this is a great thing we can do for Ottawa Centre here for anybody, is to, if you have something that you think other members might enjoy, we've got a nice door prize system here. So there it is. So from one member to another, and now on to another.
Okay, let's take a break. Come pick up your raffle tickets during the break. Take one, leave one behind, and at the end of the meeting, we'll raffle off the door prizes, which also should mention Larry Stewart brought a bunch of door prizes as well. So thank you, Larry, for that. All right, let's go to the next presenter is Richard Alexandrowich. He's going to be talking about life potentially on in other red dwarf systems.
Good evening, everybody. Okay, so lately, in terms of planet hunting, we've been looking around stars, G-class stars very similar to our sun, more or less. Astronomers have been looking for planets around large stars, small stars, you name it. But, using logic, thinking about stars that mimic our sun. But now, with Kepler going on in its second phase, it's starting to, I think, pick up stars, not only the G-class stars, but of the K and the M stars, and so on and so forth. After all, there's quite a lot of these red dwarf stars. So we'll start off with the European Southern Observatory's HARPS study, the ESO. HARPS, which is an acronym of High Accuracy Radial Velocity Planet Searcher. You're always a tongue full of these acronyms. It was installed in 2002 on the European Southern Observatory's 3.6 meter scope at La Silla Observatory in Chile, and it features a high precision Echelle spectrograph. Now, since 2012, it has the precision, or had the precision, to detect habitable super-Earths around low-mass stars. So what they have found so far is that there's tens of billions of these planets, not much larger than our Earth, and are expected to orbit in the habitable zones around red dwarfs. These are the late K and M class stars. So this is a sort of a 3D look at the Hertzsprung-Russell diagram. You can see all the stars. The top left-hand corner are the most luminous stars. They are the blue giants, supergiants, and of course the red supergiants over at the other end. And of course, you've got the main sequence going down here, and the red dwarfs. These are the M stars that we'll be talking about tonight, and the planets that are in the system around them. Of course, you can, by reading the Hertzsprung-Russell, it's not that difficult. Using the bottom line, you can tell the spectral class, which vis-a-vis will tell you the temperature, the surface temperature, the photosphere of that particular star. And of course, the higher you go, the more luminous the star gets. And of course, the lines of constant radius, as you go up, theoretically, the stars get bigger and bigger in radius or even diameter. So Kepler has been looking at stars. This is an inventory. I call this peaches and cream corn. If you eliminate the top few lines, it does look a little bit like a sample of corn on the side. But these are all the suns, or some of them, from the inventory of Kepler data. These are the G-class stars, and of course some of them are blue. There's blue dwarfs, of course, but as you can see, they're all different shades of yellow, and I believe our sun is right over there for comparison. So that's quite a lot. You know, you're looking at the Cygnus area of the sky that Kepler has been looking at. Now Kepler's his field of view is now sort of say 360 degrees, and it's including more stars in its inventory as well. So red dwarfs, well, why not? There's lots of them in our galaxy, and of course in the universe. They're faint and diminutive, and these special stars may make up as much as 80% of the stellar population in our galaxy. That's being rather conservative. Some books say 75, some say 80%. So of course this notion reinforces the growing interest in these M-type class stars, or dwarf stars. At this point in time, the research is being carried out on stars similar to our sun, like the G1s here to Kepler, and with ground-based telescopes. Now that there seems to be a shift to look at red dwarfs, does this leave any room for biosignatures? Well, before we become all excited about all this, there are several factors or limitations to consider and that need to be discussed. Okay, comparison of a red dwarf to the sun on the top left-hand corner. The red dwarf here, Gliese or Gliese, it depends however you want to pronounce it. The red dwarfs next in line as far as size. They're rather diminutive. Tidy or Tied1, which is considered the upper limit of a brown dwarf. And they're Gliese 229 and in comparison to Jupiter. So there's a whole gamut from small to large that nature has to make. And of course the red dwarfs are much lower in temperature as far as their photosphere is concerned. So as you can see, it's no match for the sun. The sun looks quite hefty compared to a red dwarf. The mass, well, on the low end, it's about 0.075 solar mass, which means it's the upper limit for a brown dwarf. At the high end, it's about 50% of the solar mass. That is for a red dwarf, so they cannot go any larger than that. The surface temperature, about 4,000 Kelvin, give or take a few. So as mentioned earlier, they are the most common stars in our Milky Way. And nature has this tendency to build a lot of smaller stars, as you can see earlier on the HR diagram, than the ones that are bigger and more luminous. Because they are both small and red, their luminosity is extremely low. This means none are visible to the naked eye, unfortunately. Binoculars or a small scope are needed. The vast majority of these stars that we see without the optical aid or telescopes are larger and more luminous than our sun. So the stars that we see in our night sky, most of them are larger than our sun, about 97%, and the ones like our sun or smaller, you need optical aid. The closest to us, to give you an example, is Proxima Centauri, a red dwarf, which glows at a paltry 11th magnitude. And of the 30 nearest suns, 20 happen to be of the red dwarf variety. Translation, they are plentiful. So according to stellar models, those with less than 35% the sun's mass are fully convective. So this means that helium produced by the fusion of hydrogen into helium is continually mixed or remixed throughout the star. And this process avoids helium buildup at the core. So in evolutionary jargon, M stars will age extremely slowly, maintaining a constant and stable luminosity or spectral type for trillions of years. They'll far outlast our sun long after it's died. So in theory, nothing catastrophic happens to them, which is good in terms of life, because if there are civilizations, they could keep on building unless of other natural or man-made catastrophes. So the analogy is like the embers of a log in a fireplace. When a red dwarf dies, nothing big happens. They just die just like the embers of a log in a fireplace. But at the stage of the game, astronomers have yet to come across a red dwarf in an advanced stage of development. Simply, the universe is just not old enough. So getting back to the results from the HARP spectrograph at La Silla in Chile, observations are telling us that 40% of red dwarfs have super-Earths orbiting in the habitable zone where liquid water can exist. These stars come a dime a dozen, about 160 billion just in our galaxy alone. And planets similar to Jupiter and Saturn are found in small numbers in red dwarf systems, that making them about less than 12%. So there's the encouragement to look at planets other than Jupiter and Saturn type planets, looking for terrestrial habitable worlds. The conclusion is there should be about 100 super-Earths in the habitable zone of F stars within 30 light years of Earth. That's a very small area, basically in our immediate neighborhood. So as far as sheer numbers are concerned, the prognosis looks quite good. That being said, now we need to take into account the cons along with the pros. Now, let's look at the planets themselves. We're going to talk about axial tilt or obliquity. Can it be a determining factor in the emergence of life? Just a little bit of a Funkenwagnall definition. Obliquity is basically the angle that a planet's poles are offset from being perpendicular to the plane of a planet's orbit around the star. So here we have an example of the Earth. The Earth being obliquity, an angle of 23.5 degrees. As you know, with the sun's rays coming in from the left, the light hitting the Earth at different times of the year as it makes its revolution around the sun will give us its season. It varies the temperature and it moderates our climate. In other words, it's not too extreme. So obliquity and seasonal variations are extremely important for a world's habitability, whether it's Earth, any other planet in the solar system, any planet anywhere. So up there now, there has not been much study in this area of exoplanet research, unfortunately. Astronomers haven't been really looking into this type of work. But what we do know, red dwarfs quickly erase the axial tilt of potentially habitable planets. In other words, that tilt disappears after a few 100 million years, which doesn't give biology a chance to start up. So the tilt is nullified in short order of time, providing a limited window of opportunity for life to get going. One example is Gliese 581d. There are worlds around sun-like stars that fare much better. It takes many billions of years for their axial tilts to erode to dangerously low levels, such as Kepler 22b, around a main sequence G-type star, because our planet's tilt takes many billions of years to erode to dangerously low levels. So how it may have been altered over time is open to debate. So planets get their obliquity from impacts early in the system's history, solar system in our case, by passing stars. We had one passing by us 70,000 years ago, Schultz's star, but it didn't really create any mess. It disturbed a few comets from the outer Oort cloud, but otherwise didn't do much damage to our Earth's environment. Might have juggled a few comets here and there, but it's, I think, 20 light years away. Scientists are wondering whether it's coming back or receding away. Apparently it's leaving the solar system. And gravitational influences by other planets, especially large, hefty ones. The tilt of the planet causes the intensity of starlight in parts of the world to vary in cycles. We go back to this image again. The tilt is very important in determining seasons, temperature, climatic conditions, and whether, even in terms of geography, it all has an impact upon that planet. For instance, winter in our hemisphere, well, actually it's summer according to that one. The northern half of our planet tilts away from the sun. So let's imagine the winter is on the far side. Sunlight hits the ground at an angle and therefore must travel through more atmosphere. And as a consequence, energy drops and our days become shorter. Meanwhile, our friends down south soak up the long, warm days of summer, and vice versa. So generally speaking, the obliquity and daily axial rotations bathe the world in a smooth distribution of temperatures. The peaks, which is the highs, and the lows do not exceed about 111 Celsius or 200 Fahrenheit in variance as far as the Earth is concerned. So this is a nice, comfortable zone for our little organisms to survive. Without our obliquity, our planet would become even more unforgiving for life, and maybe we wouldn't be around here talking about it. So for instance, if a planet has an obliquity of less than 5 degrees, the equatorial regions would become wider, receiving the full impact of stellar energy. And meanwhile, the polar regions would get less energy. The result would be extreme temperature gradients based on latitude, how high above or below the equator the particular location is. So perhaps mid-latitude areas would sustain bands of habitability, so they would be confined in a narrow window. An obliquity of 0 degrees, well, there's a bit of a problem there. The entire atmosphere would collapse and gases may evaporate into space around equatorial areas and freeze to the ground in the polar regions, as is happening with Pluto. That's why the New Horizons probe is trying to get there before the atmosphere on Pluto drops, so they can analyze the atmosphere before it gets too cold and it falls back to the ground. So all this is done with a method to their madness. Gliese 581d. The star grinds away at any tilt the planet has, and this mechanism is called tilt erosion. The star's gravity pulls on the side of the planet nearest to it, and this attraction deforms the planet into a non-spherical shape with tidal bulges. You can see a similar effect here closer to home, using the Earth and the Moon as an example. The Moon's gravity creating tides here on Earth, similar mechanism. A misalignment between the two bodies' center of gravity, which is right there, the green parts here, creates a torque to the Earth. This torque aligns with the tidal bulge with the two centers of mass. Right here, the tidal bulge and the two centers of mass. And that's the reason if there was no moon around the Earth, then things would be very chaotic as far as the seasonal tilt of the Earth, because the Earth would be shifting back and forth wildly. The polar regions would be equatorial regions would become polar, and vice versa. And I don't think we really want that to happen. So over time, the mechanism forces the planet into a zero obliquity balance. So the window of significant obliquity can be crucial for biosignatures. Here on Earth, it took 1 billion years for single-celled organisms to emerge. Then another 3.5 billion years for humans to start walking on the face of the Earth. So stars with less than 1/2 the solar mass, the tilt window becomes extremely narrow. Why? Because exoplanets must orbit extremely close to a red dwarf to receive enough energy and power for any type of biology to exist. It makes sense. So cutting to the chase, short distances will produce strong tidal effects. If you take an Earth-like world in a habitable zone of a star having 1/4 the sun's mass, the obliquity reaching 0 would take less than 100 million years. That's not very much. The fact is, Earth's analogs in the Goldilocks zone around stars having about 90% of the sun's mass, the tilt will last at least 1 billion years. That gives a more ample time for something to get going. Super-Earths, those having 2 to 10 Earth masses, these are what astronomers call super-Earths. Their tilts would also quickly disappear around M-type stars. For Gliese, or Gliese 581d, it orbits an M-class star with only 31% of the solar mass. The age of the system is 9 billion years. It's much older than our system, and the planet should have lost its axial tilt a long time ago. It is also important to note that the tilt erosion process will also slow a planet's spin or angular momentum. Seasons will disappear, and then tidal locking will take place, which I shall talk about in another session later on. Planets conducive to support life around sun-like stars have tidal forces that are considerably weaker because they are farther away from their host stars. In our case, Kepler-22b may still have seasons much like ours because it still hasn't lost its initial tilt. So a planet's rotation can be altered by the presence of a moon or a double planet system, such as Pluto and Charon, gravitational disturbances or disruptions by other planets in the same stellar system. And here at home, the moon has balanced our planet against the gravitational influences of Jupiter, if in case you didn't know. It is a guardian planet because Jupiter has warded off comets and asteroids that would decide to venture into the inner solar system. But without the presence of Luna, the Earth's obliquity may be in jeopardy. Over the aeons, Luna has preserved axial wobbling, keeping our seasons in check. So what about Mars? This is not to scale, rather, but to show how close Mars and Jupiter are. Well, enormous Jupiter wreaks havoc with the red planet and its tilt. The variance is 60 degrees over the course of 1 million years. So the result, large swings in Martian temperatures and glacial cover. A climatic chaos of this magnitude could place constraints on life. And maybe, just maybe, as I was doing a little bit of reading about this variance of 60 degrees may have played a role in the disappearance of water on Mars. Aside from the low magnetism, solar winds and radiation blowing the atmosphere away, maybe this tilting back and forth may have been producing stress on the planet itself. So in closing, as far as Gliese 581d and Kepler-22b are concerned, there is definitely more work to be done. With today's tools, gauging a terrestrial-sized planet's angle of spin remains still a difficult task. The ultimate goal for exoplanet hunters is to understand how obliquity is lost, how it's established, and in the long run, how this mechanism determines the climate of an exoplanet. But what we do know is that the tilt of any planet and how it's maintained can be a key factor in determining whether life exists or whether life perishes. That's it. Thank you.
Questions or comments?
Yeah.
Thanks, Richard.
Okay.
Okay, observer reports. Thanks again, Richard. Would Gordon, Shane, Paul, and Gary please come up to the front here, and I'll stand in for Janet. So I'll do these observer images quickly. Gordon, over to you.
Good evening. I'd like to say it was due to my ecological concern that I forgot my notes at home, but I just forgot to print them, so I'm going to have to read them off my phone. So, first up we have 2906, which is in here somewhere. Bear with me a sec. Anyway, so it's a galaxy in Leo, and it was observed on the 24th of March in Orleans, I believe. On phone, cooperate. Next, please. Okay, so this is Hickson 44, which is consists of 4 galaxies, and I managed to get 3 of them. Where's the button? Top one? Okay. So there's 3190, 3183, 31, can't remember the other two numbers, but anyway, this is the core of one, and the missing one should be right about there. That's also done in Orleans with my 12-inch scope. Next, please. The Cocoon Galaxy. This is done on our FLO tour back in April. And so we've got the Cocoon here with another galaxy, the other part of the Cocoon Galaxy there. Okay, next please. 3607 and 3608, those are in Virgo, and again, done in Orleans, here and here. Next please. And that one, I can't even see it from here, but that's mislabeled. That's actually 4567 and 4568, which is the Siamese galaxies. I think they're up there. And then, what is it, 4564 is this galaxy down here. That's I believe in Virgo. Next, please. That was done out at the FLO in May. And then this, I hope you're seeing that better than I am. Crater Schiller is done in Orleans with my 12-inch again. And the trees are really starting to take over my backyard, so my window for observing this stuff is getting shorter and shorter, and I'm finding I'm getting more and more incomplete sketches. But anyway, this one took about 25 minutes. Okay, and I think that's it. Thanks.
Tired of seeing me here yet? I'm actually going to start with this one. This picture was taken June 22nd at about 11 o'clock that day. Give you a bit of background if you're not already aware of this. I presented some other solar pictures last month. I've set up my solar telescope in the backyard, and because I work from home, I can actually observe the sun fairly often and image it. And that day I had taken this picture and was quite pleased with the result. And then later that day, I believe it was about 2 o'clock, we had this solar flare. And if memory serves correct, I think it was an M6.5 solar flare, which produced both solar and geomagnetic storms. And yeah, I was quite lucky to see this one. I took a quick look through my scope and I immediately knew that I wanted to get a picture of this one. And I knew that these are very fast. I actually took a picture of 4 pictures of this. 12 minutes later, you can actually see it's decreasing in size. And so, as you can see here, before and then after, and then as I said, it was already decreasing 12 minutes later, and then I took another one at 5 o'clock, and it's greatly reduced. But this solar flare created from a friend of mine that's RCMP in Saskatchewan, horizon to horizon auroras that night. Unfortunately, we were clouded out for the next 2 days, of course. But just very, very lucky, doing a lot of solar observing and imaging, and this is the result that you get. I wasn't actually expecting to present these tonight. I was surprised by the fact that Mike and Chris conspired to send these pictures in and have them posted, so you get to have a look at them. So that's it.
Okay, Janet isn't here tonight, but she sent the following images that she took just recently for a Canon 5D Mark II. She says either at ISO 200, I believe she said, and 15-second shots. Next slide, please. So, and this was over Loch Leslie, I believe she said. So thank you, Janet, for submitting them. Venus and Jupiter. Paul. I didn't see you. Paul, are you here?
Is that a way?
Oh, yes. And I actually said I was going to present these for him. How could I forget? So Paul, as usual, his work is very impressive there. Obviously, you can see Jupiter with the Galilean moons there. Nicely done. And of course, Venus is blasting away on the lower right there. Really well done here. I don't know. This is obviously, I don't know how he did that. Anybody have any ideas how he was able to? I wonder if this was two separate exposures here to be able to pull out the moons of. Because this is a pretty wide field. Just long enough.
Just the magnification is what.
Okay, it's pretty impressive nonetheless.
There's Joe Bonner, who's not here this month, doing just like that.
Is that right?
600 million.
Okay, yeah, that's some pretty wide.
And one with 300 million.
Well, it's a pretty wide field, as you say. A little bit closer up here. Nicely done. But this isn't the obviously the night that the other night, right? This was I think a week or so ago.
We're clouded out.
So actually, this wasn't a week ago. This was just before. So June the 29th, as he says, the other night. So, yeah, as Gary said earlier, it's really beautiful. I really love looking at Venus, with seeing the nice arc. So thank you, Paul, for submitting those. Gary.
Thank you, Mike. Welcome to my backyard. My favorite observing area, only 60 paces away from the bed. I did this a couple of weeks ago thanks to a Ioptron tracker. Put my Canon 450D along with a wide-angle lens. In fact, Al Scott, the wide-angle lens that I bought from you last swap table, that was piggybacked onto this high, a little bigger sky. And, oops. And this guy over here, well, first of all, here's the Milky Way. Altair over here, sweet 16 star, only 16 light years away. 200 billion stars in just our own galaxy. If you took a 2 kilogram bag of red path sugar, if each kernel, each sugar grain was a star, you need 20,000 of those packages to equal the Milky Way. And yet 100 billion galaxies in our known universe. Forget about the multiverse. So yeah, for sure, 16 light years, and then 30,000 light years. And you can see the horse and the rider over here. Here's the main, or the rear leg of the horse, the main body, and the front legs of the horse. But yeah, this was very peculiar because I took 3-minute exposures. I took 5 of them, and it only showed up in 4 of them. So of course, Mike Earl, who is our resident satellite guru, I emailed him the pictures, and he came back and said it's a Spanish geosynchronous satellite, Amerinas, and it's about 37,000 kilometers away from Earth, or 3 Earth radii away from Earth. It's just that the sun happened to hit it at the right angle, so right time, centered, be in the right place. So this is off my bucket list. I got the Milky Way. Next slide. And also I got Scorpius, which we do have some fine graphics. Can I have them, please? Scorpius the Scorpion. Here we have the claws. Of course, great Saturn up here. The red star of Antares. Antares is pretty well on its last legs, converting heavier elements as it's fusing. In fact, it might go off tonight, might go off in about 1 million years. But right now, Antares takes in the orbit of Jupiter, which wouldn't be a good day on Earth if we had it in the middle. And Scorpius goes down and comes actually the stinger over the above the horizon. If you were lower down in the States, you would see the whole constellation. Okay, next slide. And just happened to shoot this the other night. This is the buck moon or the thunder moon. All I was missing was lightning over here. This is the thunder moon rising 2 nights ago. And that's it. Thanks.
Okay, just let's wrap up a couple of announcements tonight. I know we've mentioned this recently, but it's more and more in the news and more in the sort of the email chatter. The upcoming total solar eclipse in 2017. There's more and more interest in trips and so forth. The RAC is organizing with a separate company. This one here is, I understand, is filling up pretty quickly here. If you are interested, you can, of course, go on the main RAC website, but this one here includes a travel package as well. All right. Our center should almost organize something as well, I think. Maybe get a bunch of us together. But my understanding is this one is pretty well organized as well. Okay, Ron St. Martin, who's not here tonight, he sent out an email just yesterday, day before, about some training, for Los Angeles Observatory training coming up on July the 11th. He said that if you're interested in participating, send him an email at his email address, spacerocks@reuters.com. This is what's on the magnets that were handed out during Richard's presentation. So it's a little hard to read, I realize that in the magnets, but this is the address that we tell people to go to, this tinyurl.com RAC party, and that'll take you to our Star Party webpage. So again, we give these out at any kind of event, and I'm hoping it'll generate more interest. It's kind of like a little flyer, except that hopefully it sticks on people's fridges. Speaking of star parties, our next stargazing session is coming up actually next Friday, as you'll see. We hold it, for those of you who don't know, we hold it at the parking lot of the car branch of the Ottawa Public Library, right adjacent to the Diefenbacher site. We set up in the parking lot, so you can see where it says observing site there. This is just north of the Carp Fair. So the next scheduled session is July the 10th. Thank you, Chris. And with a backup date, if it's cloudy on the 10th, we go to the 11th. If it's cloudy on the 11th, we go to the 17th, and so forth. Our last attempt would be on the 18th. So next Friday, hope you can join us. It's we've had a terrific year this year. We've had I don't know, 3-4 sessions the Carp Star parties. For those of you who are members and you haven't been there in a while, shame. You should come out. It's a lot of fun, as I'm sure many of you can attest. Estelle has, our librarian, as I mentioned, has a wonderful book that she's picked for the book of the month, and I picked this up at Ottawa Public Library a couple of years ago, and I just couldn't I couldn't put it down. This Dava Sobel is an amazing author. I think she was one time a New York Times author, but this is a book about determining longitude, how we determine longitude with some of the early chronometers, the problems that were presented with by not knowing what longitude, what the exact longitude was for navigators. But this is so well written. So it's in our library, and go grab it because it's a terrific book. Highly recommend it. One of my favorite, in fact. Okay, club information. Here is some names. If you want to contact these various people, just go to that address. All right. We do have a, as I think many of you know, we do have an astronomy and sky and telescope discounts, or at least a discounted rate for those magazines. Contact Stuart Glenn there, as I showed. Right after the meeting, we've got a social event open to one and all at Perkins on Saint Laurent Ogilvie. This meeting will be posted on YouTube. Tonight it's actually not being streamed live, but usually it is for those who can't make it. But it is being recorded courtesy of Graham Hay, and it will be posted on YouTube. The meetings, as I've mentioned in the past, are available through our website. You click on any one of these links, it'll take you to a YouTube page, and you can watch it again. And by the way, it's a great thing. I've done this. As you know, I've missed the last couple of meetings, so I always watch them. And it's a great way because you can do it. It's very relaxing, and you can go back in time, and particularly if you don't understand something, you can go back and follow it. So. I think we have more than 65 people tonight. Thanks to all the speakers and organizers for making tonight a success. Next meeting is August the 7th. That's after the long weekend. And the agenda is Simon is back on talking about Mars and erosion and deposition on Mars, and And Bill Wagstaff is going to talk about a subject which probably doesn't get enough interest, which is our observing programs. Okay, and there were some changes made at the national level on the observing programs, and he's going to sort of sort all that out. I think that's something we should be giving more attention to. Okay, folks, that's it. I'm going to call the door prize. I'm going to pick the raffle tickets here, and give me about. I guess that brings the meeting to a close. Give me a minute, and I'll just get the prizes, and we'll go from there. Thanks.